thing. That's why we define now closed loop control system. So we define closed loop control system. And in this case, you have same reference input, put it on the top. You have closed loop, so you have reference input, this is plus, I'll tell you in a minute, this is your controller, and this is your system, and this is your control variable, control out. Part of it will go back and you will take care of, you put some sensors to take care of the problem which may appear, perturbations, and this goes here, and negative, positive. So this is your what's the benefit of this system? What is the benefit of this system? The benefit is, I will write down the comments, that it makes, I speak and you can write, it makes the system responses relatively insensitive. To internal parameter variations. Internal parameter variations. And external disturbances. External disturbances. So this is the main important point here. Okay. It will also improve transient response characteristics. Transient, which are a function of time, response characteristics. And it will reduce steady state errors. So what we did today, we did two things. The first thing we did that we defined system. This was taking some input as a reference input. Then we said that as a result of this reference input, we have some of our controlled output. That's what we need. But the problem was that in the open loop system, we had no way. Really, we had no way to control over the impact which are appearing due to the presence of unwanted perturbations. So what should we do? Make a feedback system in which we put some sensors which will take care of any outer perturbations. So this system has several advantages. It makes the system responses relatively insensitive to external disturbances, and it will improve transient response characteristics. It will reduce steady state errors.
What do you mean by errors?
So the error will be that what is our control output we want, how far it is from the real one, what we need, right? Because this will change if I put here external. Let's say we are measuring something and some pressure changes inherently. Then what to do? Our temperature start changing, right? So we have to take care of those to make sure that this is independent of the fluctuations. Let's put all these things in symbols now so that we can, same thing, but in symbols so that we have defined functions, and then we can really define our, our control system, and we define our responses, and we define our transfer functions. Now the game is that if you have a complicated system, let's say you have two systems in parallel, or you have two systems in series, what will happen? Let's say that when you have two systems in series, between two systems some transition will happen. And what? When they are in parallel, then after that something happens. Some external disturbance appears. Right? What happens? Hold on. Whoa. So let's put all these things in symbols. In that case, let me write down again the same system but in a different way, so that we can really work on it. It's again a closed loop system, but the way we will write it with some symbols. So let's say that we have control system block diagram. And you will see that, let's make the simple first. This is the system here.